So let's apply what we've learned to the campaign contract. Now I know it's a lot, and it's going to be summarized and recapped for you at the end. But we have these ideas. Send is an exchange, it's an interaction with an untrusted contract. We do it in 3 steps. First, optimistic accounting. Then we try it and check the result. And then third, if necessary, we revert the accounting because the attempt has failed. So we have to put everything back. We also have this idea that we want to separate concerns and we want our transactions to do one thing at a time only. We don't like it if the function talks to more than one untrusted contract at the same time. And we don't like loopy processes that don't scale. So basically our send refunds function is in a whole lot of trouble because it does just about all of those things. It has a loop here that we don't like. We have an unresolved case of dealing with a failed send. We're talking to more than one untrusted contract at the same time. It's just a real mess. It's unsalvageable. I'm going to share a rule of thumb that has served me well. And the rule is this. Whenever I see a for loop in a smart contract, it strongly suggests to me that perhaps the whole function should be pushed out of the contract and into a client. There are lots of ways to do that. It can be pushed out to a trusted client. It can be pushed out to any client, any user. But just in general, there's logic going on that may be too complex and maybe doesn't belong in the smart contract, and maybe we can achieve the goal of simplifying it by pushing the iterative loopy logic out of the contract altogether. And to give you an idea of how that's going to be done, I'm just going to comment down, well actually let's let you read it. Let's leave it like that so it's readable. But we are going to abandon that. And instead of sending refunds, we're going to have a function to request withdrawal. Or better yet, let's call it request refund. It's going to be a public function. And it'll return success. Great. Now we'll fail early and fail hard, so, well, if the project hasn't failed, then throw. Now, we know who the message sender is, and that means that we can actually find their contribution. So, if we want, we could say something like this. Right? And if it doesn't work, then throw. Now the next challenge that we have is that our funder structs are in an array, and we don't get to look them up by keys like this. We have them organized by row because we were thinking of loops like this. So we have like row 0, row 1, row 2, row 3. That's just not going to work anymore. And so again, I think the best thing to do here is to just comment it out because it's going to cause us trouble. What we really want to say is there's a mapping of addresses to funder structs. Mappings are quite different from arrays. This is a namespace where every possible address exists, and we're going to park a funder struct in each location. The advantage of using a mapping like this is that it gives us random access by key. So that means that we can actually look up these structs not by the row number, but by the actual user address. So we're going to go straight from the message sender's address to the Thunderstruck. It's going to force us to change a bunch of things about this contract before it's going to be happy. Okay, so for example, right here, we can't push onto an array. That's no good. But we can actually do a shortcut here, because we will get away with putting value right into the struct. We will also get away without even having the address. Not that anymore. We already have the address, so we don't need that. Right. Let's just clean up a little bit here. Now we are just putting the cumulative amount of each funder in a Thunderstruck in the mapping. And when someone requests a refund, we're looking up the amount that that user is owed and trying to send it to them. If that is unsuccessful, then we're going to throw. If it's successful, then we'll log refund sent away with that. And then for amount, it would be that. And so far what this function says is anyone can call it. It's going to return true or false. It's only allowed if the campaign has failed. It's going to try to send the user their refund. And if that doesn't happen, then it's going to throw. And then we only get far enough to log the event for the refund sent if the transmission was successful. So far, so good. We're also going to need a way to make sure that we don't allow this to happen more than once. In fact, we can kind of sketch this out right here by saying if we don't owe you anything, then you shouldn't use this function, just like we did in the recursive example. Now we have this problem of making sure people don't do it twice. So what I'm going to suggest we do is add another field to the Thunderstruck. And this time we'll call it amount refunded. Then we'll head down here, and what we're going to do is make this readable. So we will say amount owed is your original contribution minus any refunds they've already received. So far. I'll make that a little more readable. And this as well. And we're going to do optimistic accounting here, Because if we send the amount owed, then for that user, the amount refunded has increased. So let's break this down a little bit. We want to fail early and fail hard. So the first bit says, let's look at the contributions that this sender, this message sender, this user, has sent in, and it's stored in the funder structs in the mapping. And the member is called amount. Similarly, we have the amount refunded. So the amount sent in minus the amount refunded is the net amount owed. And if that is 0, then we're going to throw. Also, refunds are only allowed if the campaign has failed. So if the campaign hasn't failed yet, then we're going to throw. Then we're going to do optimistic accounting. That is, we're going to do the accounting on the assumption that the send will be successful. So the amount refunded increases by the amount that we're about to send. Then we actually try sending it. Now, what this early accounting does, the optimistic accounting first, is it protects us from any form of reentrance from the untrusted contract. If it comes back again, it'll find that we've already done the accounting. After we do the send and check, if it has failed, then we throw. Throw has the effect of reverting this accounting. Okay? If the transaction throws, then the accounting did not happen. We only make it this far if the transaction was successful. That is, if the message sender send amount owed worked, it returned true, then it did not throw, and we make it far enough to log an event, and then we return true. Right there. Okay, I think we're ready to take that for a test drive.